It's great to see everybody. So I'm going to be talking today about what happens when you press the buy button on that domain name that you definitely need and are certainly going to use for something someday. I'm sure of it. But before I talk about that, I'll talk a little bit about DNS and sort of the just so story behind it, which is that once upon a time, when you wanted a name for a computer, you would talk to the person who ran the hosts file. And this was just a single file that listed every single computer and the name of the computer. And you talk to them and you say, hey, add this host to the host file. Obviously, this doesn't scale very well. So eventually we want something better. OK, let's make a distributed system. Surely there will never be any problems with a distributed system. So this sort of results in the thing we're used to today, where you have .com, .org, .net, .pizza, all of these things. And you have the sort of secret domain above that, which is which is the root domain. So actually, all domains really end with a dot that we just don't show most of the time. And then below that, you have all of the other things. So this is good. You can have each of these individually have the list of domains that exist, and you don't have to have it centralized anywhere. So it can be much more scalable. But the problem is, if everyone is talking to the root domain all the time, that's not really scalable. So we'll make a bunch of different root domains. They'll all agree with each other, but you can talk to any one of them. Although that's still not really enough, because if everyone is talking to these all the time, it's just so much traffic. So we'll add some caching. Surely this will not cause any problems. Caching will only solve problems. And so when you actually look up a domain name, you can see on the third to last line there, I'm talking to 8.8.8.8, which is a caching resolver. And I don't actually talk to the root domains, but I can if I want to. So you can do dig plus trace, and it'll show you this. So that's sort of the context for DNS. But who gets to decide what domains exist, right? We have this protocol that sort of anyone could use, but we have only really one global DNS system that people mostly think of. And so this was talked about, and we ended up with ICANN, the Internet Corporation for Assigned Names and Numbers, which is a nonprofit organization that sort of runs the root domain, which means they, of course, decide what top-level domains exist. But they don't actually manage those top-level domains. So they contract that out to registries, which they regulate. And so registries own a particular top-level domain. You might own .com, .net, .pizza, whatever. And they can sell those domains. They can set whatever policies they want, although ICANN does still regulate that and choose at a high level what policies these registries are allowed to set. But you probably don't want to have to deal with a different registry for every different domain name that you own. So the sort of level that most people use are registrars, which are also regulated by ICANN. They talk to the registries, and these are the people who you actually buy domain names from. So namespace.coop, you'll be able to do this soon, or things like Porkbun or Namecheap or Google domains one time in the past. So let's talk a little bit about these regulations. So if you want to own a TLD, you can pay ICANN $180,000 to maybe get to own one. This is an application fee. You don't get it back if you don't get the domain. Once you've done that, though, and once they've gone through this lengthy process to decide who gets to run this, you pay ICANN 18 cents per domain name you sell. You provide regular reports. Price controls, probably we don't need to worry about those. Seems to be the current philosophy in ICANN land. I'm sure nobody will ever jack up any prices. It'll probably be fine. Countries sort of get to do whatever they want. So any top-level domain is a country code domain. ICANN doesn't want to get into geopolitics, so they just let countries do whatever they want. Turns out deciding what countries exist and what don't is actually geopolitics itself, but probably that'll be fine. Hopefully nobody gets mad at them. Seems to work itself out. So those are registries, so those are the TLD owners. And then you actually buy domains from a registrar. So how does this part of it work? You can pay ICANN $4,000 a year, plus more for each domain name you have. And you need to apply and get accredited. Then once you've done that, you put some data in escrow. So this is because if a registrar goes out of business and suddenly nobody can access their domain names anymore, that's pretty bad news. Of course, this policy was not always in place, right? It happened because a registrar went out of business and nobody could update their domain names anymore. Like, OK, we should have some solution for this. So now the data all goes into escrow, and there's a process for if registrars go out of business, what happens. Once you're accredited and once you've paid the fees, you can go get contracts with registries to sell domains. The details of those contracts are somewhat regulated by ICANN, but also there is some flexibility there and there's some secrecy there, which is kind of interesting. So at this point, I'd like to take a digression to talk about sort of the biggest registrar, which is actually 1,252 separate registrars in a trench coat. So I was looking at ICANN's data for what registrars exist, and I was like, why are 1,252 of them all owned by the same company? And you can see this sort of histogram. There's like a couple really big companies, and they're paying $4,000 a year for each of these, right? So you do the math, that's like $5 million a year they're paying to ICANN. Why is that? Turns out it's pretty big business. When a domain expires, if it's valuable, you want to get that domain name, you want to register it so you can resell it to somebody else. But each registrar only has a certain rate limit of messages they can send, and thus a certain number of chances to get that domain name. So you'd be 1,252 registrars, and you can have 1,252 times the chances to get that. And so this is sort of a little glimpse at like some strange incentives in this system, right? ICANN is getting a nice little chunk of change from this. It's unclear like what value this provides to anybody. I think I could imagine a better system for this than this for what happens to domain names that are expired. But this is just sort of the situation we have. Seems to work well enough for everybody. So this is just what it is. So let's now talk about the sort of topic of this talk, is how is a domain name made? And the answer to this used to be quite complicated. It used to depend a lot on the top-level domain and the registrar and all the details. But in the mid-2000s, people were like, okay, we should standardize this. We should have one protocol that the registrars and registries speak. Since it was the mid-2000s, it's XML-based. We have to live with the consequences of our actions. And of course, it deals with objects. So you have a few objects, right? You have a domain. You have a host, which is really a DNS server is what I would call it. You have contacts. So let's look at an example of one of these requests. This is creating a domain. So we have this domain create XML object. So we're creating example.com, registered for 1 year. We're setting up some name servers. We're setting up some contact info for it, which we would have had to create in the past with the contact create command, which works in basically the same way. And so I'll talk about contact info for a sec, because that is kind of interesting. There's contact info associated with every domain name. And this is like your name, which kind of makes sense, your physical street address, your phone number. This is viewable by anybody with Whois, which is this protocol that's actually not even really a protocol. It's just sort of the protocol is you send bytes over TCP, and then these bytes are displayed as text. And maybe there's some format that it follows, maybe there isn't. But in any case, everyone can see this, which people don't tend to want. So you can pay a service to use their contact info instead of your contact info. In 2018, and some TLDs don't let you do this, so you just have to have your address and phone number. In 2018 with GDPR, people decided, oh, maybe it's not the best that everyone who has a website is just doxxed all the time. So there's been some transition to this domain privacy being the default and being something that's actually supported by the registrars and registries. And at the same time, they switched to this JSON-based format called RDP instead of just sending unstructured text around everywhere. So by 2025, Whois will be deprecated, and it'll be under the hood, this JSON-based thing. But you probably will not have to worry about this unless you deal with the ins and outs of this. Extensible provisioning protocol. I showed this example of creating a domain. So you can create domains, you can renew them, you can transfer them. You can update your name servers, the addresses. You can create and update contact info. And these are sort of the main things you can do. It is extensible, so you can also add other things to it if you need to, if the registrar and registry both support it. But this is kind of a remarkably simple protocol and simple set of things, right? That XML blob that I showed you is basically what you need to do in order to be a registrar. So we have this technically very simple system, right? EPP is very simple. DNS is fairly simple. You can write software that deals with these protocols in a weekend if you're fast. And really the complexity of it is all in the political and organizational systems. And I think this is a very valuable lesson if you look at DNS as this example of a system that is one of the oldest and most ubiquitous computing systems that we have. Why has it lasted this long? I think the answer is because there is all of this organizational effort and organizational complexity. And if you're trying to build something that you want people to use or you want to last, I think it's really important to focus on the organizational complexity and the political complexity in it, often even more so than the technical complexity in it. So that's what I have for you today. Like I said, namespace.coop is the domain name registrar I've been working on with some friends. And if you have any questions about this or worker co-ops or want to chat more about this, come find me afterwards or find me online. Thank you.